Yo, what's up everyone? Welcome back. Patrick here. Moving on to the next question. We got to find this limit here. The limit as x approaches 16 of 16 minus x all over the square root of x minus 4. Now, first thing you always want to check with a limit, a direct substitution. So if we sub in 16 for all the x values, notice that we're going to get 0 over 0. So unfortunately, that's not going to work. We're going to have to use a different strategy here. And there's actually two ways to do this. So the 16 minus x, I actually want to talk about that. Now, let's pretend that we had 16 minus x squared instead. What does this factor into? That's a difference of squares, right? It's 4 minus x, 4 plus x, like that. So just in general, if you remember difference of squares, that's basically the formula right there. Going from here to here, you're pretty much just square rooting this, putting that value here, square rooting this, putting that value there. So we square rooted the 16, got 4, square rooted the x squared, and got x. But notice in this case, we don't have an x squared there, we just have an x. So how would this change if this here was just an x? Well, we would be square rooting that x. So this would be the square root of x. That would be the square root of x. And hopefully you see where we're going here. Notice that we have a very similar factor in the denominator. So what's going to happen, the next line here is basically this 16 minus x becomes this 4 minus root x, 4 plus root x, all over root x minus 4. And notice that the 4 minus root x minus 4, they're almost the same, but not quite. But we can make them the same by factoring out a negative from either or. So what I'm going to do is I'm actually going to take out a negative from this factor. So it would end up being, the signs would change. We'd end up having negative 4 plus root x, which is the same as root x minus 4. And then over here, we would still have that 4 plus root x. Remember, we're only taking out a negative from this bracket, from this factor, all over root x minus 4. And now notice these cancel out. And now we can do a direct substitution, plug in 16 for x here. Root 16 is 4, plus 4 is 8, times negative 1. Answer is negative 8. So that is the answer to this limit. Another way you could have done this, it's a little bit more complex, is with a change of variables. So what we can do is we could say let m equal this root x over here. So that means m squared equals x, right? If we square both sides here, m squared equals root x squared is just x. So notice we could sub in for this root x, this m, and then for this x, we could sub in m squared. And then notice as x approaches 16, m is approaching 4. So we would sub in for that x approaching 16, m approaches 4. Right, so let me just split these up. So basically, we would rewrite this limit as the limit as m approaches 4 of 16 minus, for the x we're putting in m squared, for the root x we're putting in m, like that. And now notice this is a lot nicer to work with than that. Basically what's going to happen is we're going to end up factoring the top. And then to make this and this the same, we factor out a negative from one of them. Let's actually switch it up in this one. Let's factor out a negative in the denominator. You can do it in the numerator in this bracket as well, but I'm going to take it out of this. So this here would become 4 minus m. These cancel out. Now we can do a direct substitution. Plug in 4 for m. 8 divided by negative 1 gives us negative 8. So whichever way you do it, I feel like this way is a little bit easier. You don't have to worry about bringing in a new variable, but whichever way you do it, negative 8 is the final answer.